This is the problem 2. So the first question is we need to find the probability x2 equals to 1. And we can rewrite this is this. We have two cases. The first case is x1 is 0 and we finally get 1. And the x1 is 1, finally we get 1. So we can get the probability of x1. So we can calculate this equation. And the final result is 0.64. And let's look at the question B. We need to find the probability of x3 equals to 1. In this question, we can use matrix. So this matrix, we can write the probability sk plus 1 equals to 0 in the condition of xk equals to 0, like this. So if we square it, we get the matrix is also 2 by 2, and this at this position, the value means when x1 is 0 and we find out that x3 is 0, this is its probability. So also we can use the question A equation. So also we can this metric times this matrix. So we can finally get the probability of x3 equals to 0 and x3 equals to 1. And let's look at the question C. We need to calculate this probability. We can write it as this. The probability of x1 equals to 0 and x3 equals to 1, we can rewrite it as this, because the probability this probability is equals to this over p x1 equals to 0. So we can write it as this. And oh, yeah, this we can in the question B we calculated this. I explain it from the question B, so we can use the metric, square the metric to get this probability is here. So we can we get this and this, so we finally can calculate it. If the final result is 0.176. And let's look at the question D. We need to limit the probability when n is infinity. We need to unpower this matrix. We need to calculate it. So I assume that the probability, the probability when it close to the infinity, infinity and infinity plus 1, the probability is the same, so it's limited. It is limited, so we can write it like this. This is uh, this is infinity probability, and this is infinity plus 1. So we can get the function, and we calculate a equals to 3 over 7. So this we finally get the result. And the probability of x infinity equals to 0 is 3 over 7.